So we will be learning about insertion sort using an unsorted array A. So as you can see in this blue box array of 8 elements, numbers are present. So we will be learning in according to the integer data. 6, 5, 3, 1, 8, 7, 2, 4 are the values in the respective element indexes 1, 2, 3, 4, 5, 6, 7 and 8. So the starting element index is 1 and not 0 like given in many programming languages like C, C++ and Java. So this example has been derived from the CLRS textbook, which has in all its explanations given that the starting element is considered to be 1 and not 0. And so in insertion sort, the element 1 is assumed to be initially sorted. Like that is why there is a partition here. We have assumed that this left subarray is sorted and the right subarray is unsorted. And we are considering that the first element 6 is already sorted because otherwise we won't be able to compare. And we start with the element 2 of the array. For example, in the coming videos I will be showing you according to the algorithm that we will be taking the first element to be second and not 1. So we put element 2 in the variable k. We are taking a variable k here. In the algorithm we will be taking a variable key, and in the short we are writing as k, and we are assuming that 5 is getting input into the variable k. So in the next diagram we are just emptying 5 here. We are not placing any value here. We are simply copying it to the variable k, and we are comparing 5 with 6, and since comparing after comparing we get that 6, the first element, is greater than the second element 5. That so we are shifting 6 to the right and we will be placing 5 into the first element. So this is not a swap operation but simply a shifting operation. Now index 1 and 2 are sorted subarray and index 3 to 8 are unsorted subarray. Similarly, we are taking the value 3 here of the element index 3 to be k here. It is written now k equal to 3 from the unsorted subarray index 3. And we are emptying the array index element 3 and we are comparing the value 3 with second element 6 here. Since 6 is greater than 3 or 3 is less than 6, so we are shifting 6 to the right, and again we are comparing 3 to 5, and since 5 is greater than 3, so we are shifting 5 to 2, and we are simply placing 3 on the first element position. So the elements of 1 and 2 have got shifted to one place right, and the value present in 3 has got its correct position on the first index. So the correct sorted subarray is 3, 5, 6 and unsorted subarray is 1, 8, 7, 2, 4. So now k is equal to 1 here, and similarly we are just emptying the array element of 4 here, like we are copying it to the variable k, and we are now comparing it with element at index 3, and since 6 is greater than 3, 6 is greater than 1, we are shifting it to the right and comparing 1 with 5. 1 is less than 5 or 5 is greater than 1, we are shifting 5 to 3, and similarly 3 is greater than 1, so we are shifting 3 to 2, and we are placing 1 at its correct position on the element index 1. Now the sorted subarray is 1, 3, 5, 6 and the unsorted subarray is 8, 7, 2, 4. You can see that the array has been partitioned in the middle here, and since equally the array is now equal in size of both subarray, left subarray and right subarray. And the next element is at 5. We will be taking k equal to 8 here and compare it with 6. Since 6 is less than 8, we are not going to shift 6 to the right, but simply place 8 at 5 and just move the bar to the right. And now the sorted subarray is 1, 3, 5, 6, 8 and unsorted subarray is 7, 2, 4. Now we will be taking k equal to 7 from here and emptying this position. And we will be comparing we will be comparing 7 with 8. Since 7 is less and 8 is more, so we are going to shift 8 to the right. And we will be comparing 7 with 6 here in this array. And since 6 is less than 7, so we are not going to shift 6 to the right, but simply place 7 to the position 5 and move the bar in the sorted subarray will be till 6th index and the unsorted will start from 7 to 8. Now k equal to 2 because this is the first unsorted subarray's element value. So k equals to 2 and we will be comparing 2 with 8. Since it is greater, we will be shifting it to the right. 7 is greater, we will be shifting it to the right. 6 is greater, we will be shifting it to the right. 5 is greater, we will be shifting it to the right. 3 is less, sorry, 3 is greater, so we will be shifting it to the right. 1 is less, so we will not be shifting it to the right and simply put 2 to the position 2. Now only one element is left, which is 4. So we will be putting k equal to 4 and emptying this position, and we will be checking in the same manner like we checked before also. 8 is greater than 4, shifting it to the right. 7 is greater than 4, shifting it to the right. 6 is greater than 4, shifting it to the right, and so on till 5. Because 3 is less than 4, so we will be placing 4 in this position. And the sorted subarray looks like this: 1, 2, 3, 4, 5, 6, 7 and 8. So this is how we sort according to the insertion sort. This was just as insertion sort's intuition.